Hello, my name is Daniel, and I am going to explain this code to you. So, use me the number. So, the first line hashtag includes servo.h. This line includes servo library, which provides the necessary functions to control the servo module. And the second line, servo myself. This line creates an instance of the servo class named myservo. This object will be used to control the servo module. And second line, which is this one right here, is find trick pin 8. This line assigns the name trick pin to 8 to pin 8. This pin is used to send trigger calls to the auxiliary sensor. And so second line, define echo pin 9. This line assigns the name to echo pin 9. This pin receives the echo calls from the auxiliary sensor. And then this line right here, define in 1, 2, define in 1, 2, define in 2, 3, define in 3, 4, and define in 4, 5. These lines assign names to the pins of the motor driver. In 1, you should control one motor, or in 3 and 4 control the other. And then one duration. This line declares a variable distance or type in to store the calculated distance. And then we go to serial.begin. This line initializes serial communications at a band rate of 9600, which allows the adults to send data back to the connected computer for debugging and monitoring. Now let's go to the next line. Pin with trick output. Me. Yes, pin with trick pin output. This line configures the trick pin as an output, meaning it will send signals to the sensor. Then the next line is pin with echo pin input. This line configures the echo pin as an input, meaning it will receive signals from the auxiliary sensor. And in one output. Pin one output and still pin one pin mode input one in one output. This and they all this whole operation needs the same thing. So the computer what to treat just treat it as an output or treat it as an input. And and then my servo. So to attach 10. This line attaches the myself object in 10. It makes the code to control servo to connect to that pin. And my servo does write 90. This line sends the servo motor to 90 degrees, which is typically its center position. And the delay after this line causes the program to 500 milliseconds, giving the servo time to move to the specified position. And then get distance and then insert distance. This line includes yes, and get this get this and this are this are right. Check below this one right here. Um, this right here, the trigger pin to show it is known. It's showing it is in unknown state. Usually it's makes it off, and then this one right trick pin hand makes it on, and then it will delete him is I think it's 10 microseconds for to trigger pin low again, and then the duration equals pulse echo pin high. This line measures the time in microseconds it takes for the echo pin to go from low to high and back to low. This duration repeats the time as sound waves traveled. And this one, this time equal duration times 0.034 slash 2. This line calculates the distance in the centimeters. The speed of sound is approximately 0.034 centimeters. I mean, microseconds. The duration is divided by 2 because the sound waves travel to the objects and then back.
Hi, hi, my name is Daniel, and I'm going to explain this how this car works. So first we have this thing right here, which is called the motor driver, and because the Arduino board that doesn't have enough power to power the motor driver is used to amplify that power and make the motors run smoother. And this is known as the battery holder, and is used to hold the batteries, which are the primary source of power for this car. And this right here is the Arduino, which is what we are using to wire everything together. And this is a tiny like circuit, which is kind of like the brain of the whole car and everything. And this is the servo motor, which is used to move this thing around. This is the ultrasonic sensor, which is used to sense objects and things in front of it. And the things inside here are the DC motors, which are used to spin. I'm gonna show how it works. So this is what happens when it starts working. The motors start moving forward constantly, and this right here looks for anything in front of it. And if you see something, the motors stop. Then it will look left, right. Then if there's any way to the left, then it will turn to the left and go there. If it is to the right, it will turn to the right and go there. And if not, then it will turn around and come back. And it will turn because of this thing which is called the servo motor, which will make it out to turn. So I'm going to connect it up to show you guys how it works. So 3, 2, 1.